All right, for assignment number 9, we are looking at derivatives and using our derivative shortcuts here. So let's see, we're doing number 1. Use the graph to estimate the slope of the line tangent to y equals x to the n at the point 1, 1, and then verify your answer analytically. So if I were estimating the slope here, it looks like, I don't know, maybe 1/2. Like it looks like we go up a half unit and across 1. So my estimate for the slope is 1/2. But we know that we can find dy dx, which is the derivative, the equation for the tangent slope. I'm using power rule here, so bring down the power, subtract 1 from the exponent. So 1/2 minus 1 is negative 1/2. And then we rewrite that. So this is 1 over 2. I'm going to write it as square root x. So that's my equation for the derivative. And then I want to evaluate the derivative at the ordered pair 1, 1. My derivative equation only has x in it, so I'm just plugging 1 in for the x value. The y value is irrelevant there. So I do confirm that I get 1/2, just like I did for my estimate there. All right, and then for part B, same idea. So I'm going to estimate that it looks like maybe this is an x to the third graph. It looks like a steeper slope than just 2. So I'm going to guess 3 because I see the x to the third there. You're not really going to be asked to guess from just looking at a graph. You would have an approximation. You would have like a table of points or something. But anyway, if we find dy dx using the power rule, we pull the 3 out in front times x to the 3 minus 1. And then we evaluate dy dx at the ordered pair 1, 1, which means we're plugging in 1 for x. And we do, in fact, get 3. So that matches kind of what the picture looks like. All right. For the next section, use the rules of differentiation to find the derivative of the function. So again, we're just using our shortcuts here. The derivative is f prime of x, and that should just equal 1. For the next one, f prime of x is equal to, so this becomes 6x squared minus 2x plus 3. When you have exponents that could be negative, it's a good idea to rewrite them. You're not required to do this, but it tends to eliminate mistakes if you rewrite this as 5/2 times x to the negative 2. And then differentiate, so make it y prime or dy dx. So this is going to be 5/2 times negative 2, so negative 5. And then it's going to be x to the negative 3, because we do negative 2 minus 1. And then we simplify, which just means rewrite so that you don't have negative exponents. So that's our dy dx. For the next one, I'm going to rewrite this as well. So 2/3 times x to the negative 2. And then we'll differentiate. I can call it dy dx or y prime. It doesn't matter. So 2/3 times negative 2 is negative 4/3, x to the negative third. And then to rewrite this without negative exponents, that's negative 4 over 3x to the third. This time the 5x is in parentheses, so I'm going to simplify this to be 6 over 5 to the third is 125, and then x to the negative third. I don't want to bring it out as I don't want to do this because we have not talked about chain rule yet, and if you just do this, you won't get the right answer. Oh, wait, it'd be negative 4. But you won't get the right answer if you do that. So if you see parentheses, simplify them first. Y prime, we'll talk about chain rule probably tomorrow. Okay. So 6 times negative 3 is negative 18 over 125. And 125, I know, is not divisible by 3. I know this doesn't reduce because its digits do not add up to a multiple of 3. They add up to 8. This is x to the negative 4. So y prime will be negative 18 over 125, x to the fourth. I just want to check my answer key that I posted to see if I subtracted that. Oh yeah, I did. Okay. All right. Same thing for this one. The original function is pi over 3x squared, so I'm going to do the same thing. I'm going to make this pi over 9 and then times x to the negative 2. So when I differentiate dy dx, or y prime, I get negative 2 pi over 9 times x to the negative third. And then dy dx is equal to negative 2 pi over 9x cubed. Sorry, I keep checking this, but yeah, okay. I must be getting mixed up with a different homework exercise. I feel like I was getting different answers. Okay, anyway, next set of problems. Find the slope of the graph of the function at the given point. Use the derivative feature of the graphing utility to confirm your results. So find the slope means find the derivative and then evaluate it at this point. So f prime of t. Oh, so this is just a linear, or no, this is not a linear function because the t is in the denominator. So when I do this, I might want to first I might want to rewrite f of t. 3 minus 3/5, and then this is t to the negative 1. So f prime of t is equal to 3, and then negative 3/5 times negative 1 is plus 3/5. It'll be times t to the negative 2. And then when I evaluate this at 3/5, that'll be 3 plus 3/5. And then the t squared is going down here. So 3/5 is getting squared, which is pretty ugly right now the way it is. So let's see. So this is 3 plus 3 over, so 5 times 9 over 25 is 9 over 5. And then I can make that 3 plus 15 over 9, which reduces by 3. And then my work's getting kind of ugly here. 9/3 plus 5/3, getting a common denominator here, is 14/3. And then we can confirm that on our calculator. So we can go to math and deriv, which is option 8. Type in the variable that you're differentiating with respect to. Type in the equation, 3 minus, now remember, you either need to do this, 3 divided by 5x, or you can do 3 minus, remember there's this little fraction thing here. So this is kind of nice because it's silly when the parentheses are the thing that messes you up. You don't want to miss points for knowing the calculus and just not knowing how to type it in your calculator. So, okay, so we have that. And then as a fraction, oh, I can't do it as a fraction. Let's see, 14/3. Oh, wait, I didn't get the same answer. Okay, so I need to check something and see what I did wrong here. So let's see, where did my math go wrong? Probably somewhere down here, right? So 3 over 5, let's see, 5 times 9/25 is 9 over 5. And we've got 15 over 9, if I reduce by 3, is 5 over 3. Oh, that's silly. I changed the problem from a, oh no, that's not right, a minus to a plus. Let's see if I can find the answer, what I did wrong in my answer key here. Oh, okay, I see it. So, silly mistake here. The derivative of 3 is 0. Sorry, you're probably yelling at me all throughout my video here. Okay, so the answer is not 3 plus 5/3. The answer is just 5/3. Okay, so 5/3. It's great when the explainer video has an error in it. So 5/3 is the answer. Good thing I confirmed with my calculator, right? 5/3 is the decimal of this set. All right, let's see how we do on the rest of these. Okay, 39. Find the derivative. So f prime of x is equal to, this is going to become 2x. 5 will become 0. Minus 3x to the negative 2 is plus 6x to the negative 3. And then we should always rewrite our answers. So this is 6 over x to the third. You don't have to do common denominator or any of that. We just want to get rid of negative exponents. If we're working with the derivative further, we will start to combine, but we don't need to do that today. If you see f of x is divided by a monomial like this, we don't have the quotient rule yet, and we wouldn't want to use it anyway. Remember, from pre-calc, this kind of forms a heart. You're allowed to divide both terms by x. Another way to think of it is factoring x out of the top. So f of x is actually 4x squared plus 3x, and then f prime of x is equal to 8x plus 3. Remember that these are exponents of 1/2. You might want to rewrite them to begin with. This is x to the 1/2 minus 6x to the 1/3. So then f prime of x is equal to 1/2 x to the negative 1/2 minus 6 times 1/3. So minus 2x to the 1/3 minus 1 is negative 2/3. And again, I'll just rewrite my negative exponents. So 1 over 2x to the 1/2, or I could make that radical x, minus 2 over x to the 2/3, or that could be cube root of x squared. But I'll just leave my answer like this. Okay, for 55, part A is find an equation of the tangent line to the graph at the given point. B is use a graphing utility, which I kept up here. And C is use the derivative feature to confirm your result. So find an equation of the tangent line at a point. So we have a point. We need a slope. The slope is dy dx, or y prime. The slope equation is 4x to the third minus 6x plus 0. And we want to evaluate dy dx at the ordered pair 1, 0. So we plug 1 in for x, and if we had y's, we would plug in 0 for y. Oops, I said 0, so I plugged in 0. Okay, so 4 times 1 minus 6 times 1 is negative 2. Here's my equation for my line. Y minus 0 is equal to negative 2 times x minus 1. You don't have to have the y minus 0 in there. You could just have y equals. If I graph that line with the curve, it looks to be tangent, so that's a good sign. This is at the point 1, 0. And n-deriv, I'm not sure what they do to actually calculate the derivatives, so it's not giving me exactly negative 2, but we do round to 3 decimal place accuracy, so it is negative 2 for the slope. It's kind of good to know that, though, that this isn't always, something is throwing this off. I'm not sure how they calculate that slope. Determine the points, if any, at which the function has a horizontal tangent line. So if a horizontal tangent line, that means that the tangent slope is equal to 0. That means that we need to set y prime equal to 0. And so in order to do that, we need a y prime equation. So the first thing I'm doing is rewriting the y equals equation, and then I can find y prime. That's negative 2x to the negative 3. Y prime is equal to negative 2 over x to the over x to the third. So here's a reason why we rewrite our negative exponents. The goal is to set negative 2 over x to the third equal to 0 and solve for which x values make that true. If I don't move the x to the denominator, I might accidentally say x equals 0. But that's not the case. If x equals 0, you're undefined. If there's no x in the top of the fraction, remember range, this derivative function never equals 0. If you multiply x cubed over to this side, you get negative 2 equals 0, which is never true. So there are no horizontal tangent lines for this particular function. The 1 over x squared graph, by the way, looks like this. It's got both of its branches here. So there are no horizontal tangents. I sketched this pretty poorly, but we have horizontal asymptotes at 0, but there's no point where you're going to get an actual tangent of 0. We're doing 76 here. So the graphs of a function f and its derivative f prime are shown. So I did not erase what I wrote for this. We're trying to say which one's f, which one's f prime. Now that we know about derivative rules, we know that if f of x is some sort of quadratic, then f prime is always going to be some sort of linear function. So even though these are not the equations for this particular parabola and line, the f would have to be the parabola, and f prime would have to be the line. You can't switch it around, because if you took the derivative of a line, you wouldn't get a parabola, you would get a horizontal line. All right, true and false. I didn't erase my answers, but I erased my reasoning, so let's see. If f of x equals g of x plus c, so f is a vertical shift of g, then f prime equals g prime. So this is true because if I take the derivative with respect to x of both sides of the equation, which is something you can do, by the way, just like we can square both sides, we can divide both sides by 2, we can take the log of both sides, we can take the derivative of both sides with respect to the same variable. That makes this f prime of x. That makes this g prime of x. And then the derivative of a constant becomes 0. So that is true, that you get f prime equal to g prime. And for the false statement, if y equals pi squared, then dy dx equals 2 pi. So they're trying to trick you here with an exponent rule, but y equals pi squared is a constant function. It's a horizontal line going through pi squared. So dy dx is actually equal to 0. All right, for these last problems, find the average rate of change of the function over the given interval. We just did this in pre-calc. Compare this average rate of change with the instantaneous rates of change at the endpoints. So start with average rate of change. That's f of 2 minus f of 1 over 2 minus 1. Remember, average rate of change is the same as like average velocity. So what is f of 2? 8 plus 5 is 13. F of 1 is 4 plus 5, so minus 9. So the average rate of change is 4. And then we want the instantaneous at both of those values. So f prime of t, f is just linear. F prime of t is equal to 4. And I guess I didn't need to do all my average rate of change work. So the average rate of change will be the same as the instantaneous, and that's because we have a linear function. So f prime of t is equal to, f prime of, we're supposed to check at the endpoints. F prime of 1 is equal to the average rate of change, and that's also equal to f prime of 2. For the next one, f of 3.1, wait, did I have to do 94? No. Okay, we're skipping that. We're going to 95, our last one. Sorry. I didn't remember having to deal with that decimal, so let's not. Okay, so 95. F of 2 minus f of 1 over 2 minus 1. So average rate of change, f of 2 is negative 1/2. When you plug in 1, you get negative 1, so it's minus negative 1. So this just comes out to 1/2. And then f prime of x, because f of x is really negative x to the negative 1. So I'm going to get 1 x to the negative 2. So f prime of 1 is 1. F prime of 2 is 1 over 4, so 1/4. And we're comparing the 3. So the smallest is f prime of 2. That's less than the average rate of change, which is 1/2. And that's less than the instantaneous rate of change at 1. So 1/4 is less than 1/2, which is less than 1. All right, that finishes up this homework assignment. Please come into office hours if you have any questions, and make sure that what you're writing, your work, looks like my work, because a lot of us missed points in our limits chapter just because of the way you were writing things. So notation matters.